In this lecture, we will be seeing about certain problems related to dBSPL and dBIL. So the first problem is there is an increase in intensity by a factor of 2, which means the intensity level is doubled. So what will happen to the decibel level? This we have already seen in the previous classes. So dBIL formula is 10 log I0 by IR. Now this ratio is doubled, factor of 2. This ratio will be changed into 2. The formula becomes 10 log 2. Log 2 is 0.3010. Hence the formula will be simplified as 10 into 0.3010, which is 3.010, approximated to 3 dB. When two same intensities are added up, it will result in 3 dB increment. So 60 dBIL and another 60 dBIL will provide a resultant intensity level of 63 dBIL. This is two intensity level is added up. Now same we have see if 10 different sources producing same intensity, what will happen to the intensity level? 10 log, the ratio becomes 10 times. So 10 log 10. You need to find the value of log 10. Log 10 value is 1. So there will be an addition of 10 dB. For example, here in this graph, you can see that the x-axis is the number of sources. When there are 2 sources, there will be an addition of 3 decibels. When there are 3 sources, the addition from the combined source is going to be 4.8 decibels. So 50 dB plus 50 dB plus 50 dB will be resulting 54.8 dB. When there are 4 identical sources of sound intensities, it will result in 6 dB increment of the total intensity. So when there is 10 sources, there will be an addition of 10. So 90 dB, 90 dB, there are 90 dB sources. The resultant energy will be just 100 dB IL. Lesser the number of source, greater the increase in intensity. As more number of source increases, the summative addition will be lesser. The next problem, we need to find the intensity level of a sound whose intensity is 2 into 10 to the power minus 6 watt per meter square. So we are going to convert 2 into 10 to the power minus 6 into dBIL. We know the formula for dBIL. It is 10 log I0 by IR. So here I0 is 2 into 10 to the power minus 6. The formula becomes 10 log 2 into 10 to the power minus 6 divided by 10 to the power minus 12. On simplifying this equation, it becomes 10 log 2 into 10 to the power minus 6. When the denominator goes to the numerator, the minus 12 will become plus 12. 10 to the power plus 12, resulting the equation to 10 log 2 into 10 to the power 6. 10 Now the log is for 2 into 10 to the power 6. So this will become log of 2 plus, whenever there is multiplication, when I apply a logarithmic formula, it will becomes addition. So 10 log of 2 plus 10 to the power 6. So we need to find the logarithmic value of 2 and logarithmic value of 10 to the power 6. So log of 2 is going to be 0.3010. And whenever there is log, the exponential will come in front of the log. So it going to become 6 log of 10. 6 log of 10. Log of 10 to the base 10 is going to be always 1. So the equation will be simplified into 10 multiplied by 0.3010 plus 6, which will be 10 into 6.3. The resultant value will be 63 decibels, 63.01. So 63 dBIL. An absolute value of 2 into 10 to the power minus 6 will result in 63 dBIL. Clear? We'll go to the next problem. The intensity level of 4 into 10 to the power minus 5 watt per meter square. Make a note of this. You are going to solve this equation. Follow the same steps done in the previous problem. You will get the answer for this. Okay, so we'll go to the next problem. An intensity level of 65 dBIL corresponds to what absolute intensity? So now we are going to convert the dBIL into the absolute values. So 65 dBIL is equal to what absolute intensity? Watt per meter square. For this conversion, we are going to apply the values in the same formula dBIL. So dBIL is equal to 10 log I0 by IR. We need to find the value of I0. I0 is equal to X. Now substituting the known values in the equation, we should be able to get the absolute value X in watt per meter square. 65 is equal to 10 log X by IR value is 10 to the power minus 12. Now this 10 should be taken the other side of the equal sign. So it will be 65 divided by 10 equal to log of X divided by 10 to the power minus 12, which simplifies the equation to 6.5 equal to log of X divided by 10 to the power minus 12. Now we need to remove the log. So if you want to remove the log, we need to take anti-log. So taking antilog on both sides, log and antilog get cancelled. So log of antilog of 6.5 is equal to antilog of 6.5 is equal to x divided by 10 to the power minus 12. In scientific calculator, antilog is 10 to the power x. So 6.5, if we put 10 to the power x, we will get the antilog of 6.5. Now we have a huge value. So let us see how many decimal points we need to move back. So it is going to be 3.16 into 10 to the power 1, 2, 3, 4, 5, 6. So 3.16 into 10 to the power 6. Antilog of 6.5 is equal to 3.16 into 10 to the power 6 is equal to x by 10 to the power minus 12. Simplifying the equation, x equal to 3.16 into 10 to the power 6. This numerator going to the denominator going opposite to the other side of equal sign, so it will be 10 to the power minus 12. When it goes to the same side, the sign changes. It's going to the opposite side, so the sign remains the same. Now solving this equation, it will be 3.16 into 10 to the power 6 and minus 1 will become minus 6. So watt per meter square. 65 dBIL is equal to 3.16 into 10 to the power minus 6 watt per meter square. We have converted the decibel scale into absolute scale. Understandable? We'll see the next problem. So here there is a simple comparison between the intensity scale and the sound pressure scale. As we all know, intensity is directly proportional to the square of pressure. So that relation can be seen in this page. Now in SPL, sound pressure level, what happens when there is a twice increment in the sound pressure level? Because of the formula 20 log, we'll get 6 dB rather than 3 dB. In the same way, when the sound pressure level multiplies by a factor of 10, we'll get 20 dB increment. So in intensity level, when there is an increase by a factor of 2, the increment is 3 decibels, and when sound intensity is increased by a factor of 10, the increment is 10 decibels. Whereas in sound pressure level, when the sound pressure level is increased by a factor of 2, the increment is 6 decibels. When it is increased by a factor of 10, it is going to be 20 decibels. That is the difference between the intensity level and sound pressure level. But if there are identical sources which are going to be added up, then we are going to follow only the intensity scale, not the SPL scale. So we are going to use the intensity level formula for addition of two identical sounds or two non-identical sounds. Only when it is increased by a factor you are going to use this formula, otherwise you are going to use the intensity level formula for addition. Now let us convert 65 dB SPL into absolute pressure values. 65 dB SPL into absolute pressure values. So absolute pressure value is micropascal. How many micropascal? It's 20 micropascals. can also be written as 2 into 10 to the power minus 5 Pascal. Let us convert the relative sound pressure scale into absolute sound pressure level. dBSPL formula is 20 log P0 by PR, and P0 is the value what we need to find, so let us take that as X. Now substituting with known values, 65 is equal to 20 log X by 2 into 10 to the power minus 5, the reference value. Now bringing the value 20 on the other side of the equal sign, it's going to be 65 divided by 20 is equal to log of X divided by 2 into 10 to the power minus 5. Let us simplify this equation. It is going to be 3.25 is equal to 3.25 is equal to log of X divided by 2 into 10 to the power minus 5. If I want to remove the log, I need to take anti-log on both sides. Hence the equation becomes anti-log of 3.25 equal to X by 2 into 10 to the power minus 5. Anti-log of 3.25 equal to X divided by 2 into 10 to the power minus 5. Let us use the calculator to find the anti-log. The value is 1.778. Okay, 1.8, 1, 2, 3. Yeah, 1.8 into 10 to the power 3. Anti-log values simplified into 1.8 into 10 to the power 3 equal to X divided by 2 into 10 to the power minus 5. Now X equal to 1.8 into 10 to the power 3 multiplied by 2 into 10 to the power minus 5. On simplifying this equation, 1.8 into 2 is going to become 3.6. 3.6 into 10 to the power minus 2 pascals. 3 and minus 5, so it will be simplified into minus 2 pascals. Now 65 dB SPL corresponds to the absolute pressure of 3.6 into 10 to the power minus 2 pascals. If I need to write the answer in micropascal, Pascal is a larger value, micropascal is a smaller value. So when I convert a larger value to a smaller value, I need to multiply. So to the power 6. So when I multiply this value to the power 6, 3.6 into 10 to the power minus 2 will become 3.6 into 10 to the power 4 micropascals. So 3.6 into 10 to the power 4 micropascals corresponds to a value of 65 dB SPL. You can cross check this. Here we have a problem where there are two snowmobiles, each produce 94 dB IL. So two sound sources producing same intensity level, two identical sources of sound, which means it is equal to the sound intensity increased by a factor of 2. So 94 dB IL plus 94 dB IL, it is not direct addition, it's logarithmic addition. So 10 log, the ratio is twice. So log of 2 is 0.3010, and that will make the equation 3.010. I need to add this value from the base intensity. So 94 dB is the base intensity and the summed value is 3 dB. The resultant value is going to become 97 dB IL. When there are two snowmobiles producing 94 dB IL each, the summed resultant intensity value is going to be 97 dB IL. Let us see the same with sound pressure level. Though it is sound pressure level, we are not going to use the formula of sound pressure level in addition. While adding, it is going to be the formula of intensity level. So only the intensity is going to be added, not the pressures. So here there are 8 sound sources. So we need to find 10 log 8 times 10 log 8. Log of 8 is equal to 0.9030. 0.9030, which corresponds to a value 9.030. Let us assume it to be 9 decibels. The base intensity is 92 dB. So 92 plus 9 will become 101 decibels. The resultant intensity at this particular example is 101 decibels. Is it clear? While adding, we need to, whatever may be the sound intensity level or sound pressure level, we are going to use the formula of intensity level. Clear? Now what happens when there are two non-identical sound sources? When there is identical sound source, we can just put a factor of 2, 3, whatever the n value, we are going to put that factor and find the value of how much we need to add from the base value. Now when there is two non-identical sound source, we need to convert the values into absolute. Relative sound intensity levels or sound pressure levels into absolute value, add the absolute value, then again convert the absolute value into decibel scale. So here we will be solving the 90 dB into absolute. 90 equal to 10 log x by 10 to the power minus 12. So when 10 comes to the other side, it becomes 9 log of x divided by 10 to the power minus 12. Taking anti-log on both sides, anti-log of 9 is going to be 10 to the power 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1 into 10 to the power 9. Antilog of 9 is 10 to the power 9 equal to x divided by 10 to the power minus 12. Solving this equation, x equal to 10 to the power 9 multiplied by 10 to the power minus 12. Nine and 12, the difference is going to be 3. This equation will become x equal to 10 to the power minus 3. Now we have converted 90 dB SPL into absolute value. The same we are going to convert 80 dB SPL into absolute value. 80 equal to 10 log x by 10 to the power minus 12, and that will make the equation 8 equal to log of x by 10 to the power minus 12. Taking antilog on both sides, antilog of 8 is going to be 10 to the power 8 equal to x by 10 to the power minus 12. X is equal to 10 to the power 8 into 10 to the power minus 12, which will make the equation x equal to 10 to the power minus 4. Now we need to add both these values. As the exponential power is of different power, either we can convert into the same power then add, or we can convert this into absolute value and add it up. So 10 to the power minus 3 can be written as 0.001. 10 to the power minus 3 is 1, 2, 3. So 0.001. The same way 10 to the power minus 4 can be written as 0.0001. So that is 10 to the power minus 4. Now we can add these two values. So on adding these two values, we will get a summed value of 0.0011. 0.0011, which can also be written as 1.1 into 10 to the power minus 3. Clear? Now the two relative intensities converted into individual absolute intensity. That individual absolute intensity is added up. This is the summed absolute intensity. Now we need to convert this absolute intensity into relative intensity to get the overall sound intensity level because of these two sources. Again, using the intensity formula, 10 log I0 by IR. So here 10 log 1.1 into 10 to the power minus 3 divided by 10 to the power minus 12, which will be equal to 10 log 1.1 into 10 to the power minus 3 into 10 to the power plus 12. Which will make the equation 10 log 1.1 into 10 to the power 9. Now simplifying this equation, it will become 10. This log is common for both 1.1 and 10 to the power 9. 10 open bracket log of 1.1, multiplication will become addition, right? So log of 1.1 plus log of 10 to the power 9. When log comes, the exponential will come in front of the log. Hence it becomes 9 log 10. We need to find the value of log of 1.1. 1.1 log is 0.0413. 0.0413 plus log 10 is 1. So it is going to be 9. 9 into 1 is 9. 10 multiplied by 9.041. On solving this equation, the resultant value is going to become 90.4 decibels. 90.4 decibels. 10 into 9.04 is 90.4. So sum of 90 decibel and 80 decibel is going to result in a value of 90.4 decibel. Clear? So this is how we need to add two sound sources of different intensity. Convert it to absolute intensity, add the absolute intensity, again convert it back into the decibel value. Understandable?